Hello everyone, I'm Fatma Abil and today I will talk about wind power systems from Renewable Energy course, which is METE 4378. First of all renewables energy except for geothermal and tidal power are unlimitedly comes from the sun, and the earth receives 1.74 times 10 to the power 17 watt of power from the sun. Also, that wind turbine converts the kinetic energy of the wind into mechanical energy first, then to the electrical energy, which is um, produce electricity. And about 2%, 1 to 2% of the energy is converted to wind energy. There are two types of wind turbine technologies, which is drag type and lift type. For the drag type, as you can see in the picture here, this is a drag type wind turbine, and this is a lift type turbine, which is vertical axis lift force turbines. And here are vertical axis lift turbine force turbines in different. There are two types for wind turbine technologies. The first one is the drag type, and the second one is the lift type. So this is a picture of drag type, as you can see, and this one is lift type, and it's this one is in a vertical axis lift force turbine. And we have many other different types of vertical axis lift force turbine. The differences are in the designing only, as you can see. And there are also lift type wind turbine in the horizontal lift force turbine, as you can see in the figure here. Here are other types of horizontal axis lift force turbines. Now for the wind turbine components. As we know that the principal working of the wind turbine, it's actually in the beginning it's kinetic energy, then it converts to mechanical energy, and lastly to electrical energy to produce electricity. So for the components, they are rotor, gearbox, and generator, and converter. And they all have different efficiencies. And the maximum theoretical efficiency is 59.3%. For the wind turbine components, of course, as we said, there are generators, gearbox, low speed shaft, and high speed shaft, main frame, and hub with bearings. And I want to mention that always the high speed shaft is always connected to the gearbox, and that's why it's a high speed shaft. And the low speed one are connected to the hub and gearbox. Most wind turbines drive trains include a gearbox to increase the speed of the input shaft to the generator, and small wind turbine rotors turn at a speed of the order of a few hundred rad per meter. Larger wind turbine turn more slowly. Brief history of windmills. First use of the wind power was to sail the ship and Nile by Egyptian. First known historical reference to the windmills is from the hero of Alexandria. He describes a device that provides air to an organ by a windmill. Al-Mas'udi, the famous geographer of 9th century, mentioned that the use of windmills in Sistanian of Iran. Sistanian windmills have continued to be used till recent times. They were drag-type vertical axis. Windmills made their first record appearance in Europe, and the idea may have been brought to Europe from Sistanian, and they were different from the Sistanian wind in design, which was horizontal axis type and were driven by the lift force. It was used for water pumping, grinding, and sawing wood and powering the tools. When European windmills were entering the final years, another type of windmills came into widespread use in USA for pumping water. These mills had multiple blades, also known as fan type, effective regulating system. Also, the re-emergence of wind energy, it is increased in size, improved performance, and technology innovation. Wind energy now cost competitive with conventional fuels. So, as you can see, from early 1981 centuries until 2010, 2010, there are a huge difference from the first time innovating in wind energy.